In this video, we're going to talk about electric potential. So imagine we have a point charge and we're going to move it from point A to point B in an electric field. This will require work to do. The differential amount of work is negative F dot dl. The negative sign indicates that the work is being done by an external agent. Now we know that the electric force is equal to QE, so we will substitute that in our expression for work. We now integrate both sides and divide out Q. The term W over Q is the work per unit charge, which we call the electric potential, or the voltage. We know from a previous video that the electric field of a point charge is this. We can substitute this into the expression for the potential. Noting that the only component of dl that survives is the radial component, we can evaluate the dot product and perform the integration. We get this as our final expression. Notice that we are defining Q over 4 pi epsilon naught r as the potential at that point. The potential between A and B is simply the potential difference between point A and point B. As a general convention, we will set the initial point to be infinity. Performing the integration again, we get this. So what if the point of observation is not the origin? Well, with a little bit of vector analysis, we can modify the formula to be this. The primed vector r means the position vector of the source of the charge. If there are multiple charges, and we want to find the potential at a point due to all of the charges around it, we simply sum up the contribution from each charge. This can be condensed into a summation formula to make things a little bit simpler. When the amount of charge becomes a continuous distribution instead of a discrete one, the summation turns into an integral, be it over a line, surface, or volume. Take a moment to convince yourself by looking at the summation formula first that these are the expressions for the potential due to a line, surface, and volume respectively. One more quick thing. If we choose our initial point to not be infinity, then there will be a constant in the expression for the potential. You may have already realized this when we first derived the formula for the potential difference due to a point charge. Thanks for watching. Be sure to rate, comment, and subscribe.